Hey everyone, it's Professor Reiko here again. We're continuing on with our discussion on bonds, and what we're going to focus on today, or I should say in this video right now, is how to determine the issue price of a bond. All right, so this is extremely important because the issue price, meaning what we're going to sell it for, really drives the rest of the problem. So this is an important number to make sure we can get correct. All right, so bonds typically have a face value. So if you think about the bond, just think of it as like an actual piece of paper or certificate. On that, it's going to have a face value. And then it's also going to have what we call a stated rate. Okay, the face value just tells you how much what the bonds are worth. Okay, I mean what the maturity value is of those bonds. All right. However, the sales price is going to be different than the face value because it's going to be determined by the economy, supply and demand, risk, things like that. What's going on in the market at that point in time. All right, so it's important that we need to be able to figure out what investors will pay for the bonds that we're issuing. Now, if you've already done the investment chapter, we've already talked through this because in the investment chapter, we were the ones buying it. We were the investors. Now we're the ones issuing the bonds. So if you haven't done the investment chapter yet, this will be new. If you've already done it, then this should be familiar to you. All right, but important here, investors will pay the present value of the expected future cash flows. All right, so anytime you see present value, you should be thinking you're going to use the present value tables, or I typically teach how to use it using the financial calculator because it is much quicker and easier to do. So the present value of expected future cash flows. All right, so expected future cash flows. So that means there's going to be cash flows in the future. All right, what are those cash flows? They are interest and principal. Typically, the interest will be something we pay out. Remember, we're the issuer in this chapter, so we'll be paying interest every 6 months to the investor, and at the end of the life of the bonds, we will pay back the principal or face value of the bonds. All right, so it says what rates are we going to use? All right, there's two rates, a market rate and a stated rate. All right, so the market rate is used to calculate the present value of the expected future cash flow. So up here, when we talked about what we're going to issue it for, we're going to use the market rate to determine that present value. All right. The stated rate is used to determine the interest payments only. All right. So this interest payment that we're going to make every 6 months, that's what we're talking about right here, the interest payments. All right, so typically when I do a problem, I will calculate this interest payment first. One, I need it at the very beginning because it's one of my two cash flows that I have to determine the present value of. But two, I like to do it first because I do it first, use the stated rate to get to that number, and then that's the only time I ever use the stated rate in the problem. So it just helps me remember, hey, let's do it first and then not ever then use the market rate for everything else in the problem. So it's just a little thing, and you'll see as we start doing examples, I will do it that way. All right, so what if the market rate is different from the stated rate? All right, this is typically the case. Now, your book may start with kind of like an easy example where the market rate is the same as the stated rate, and you won't have any discount or premium. All right, so we've talked about discounts or premiums in other chapters when we've talked about notes receivable or the short-term note payable. Things like that. We've seen the words like discount, and so we should be somewhat familiar with it, right? But let's just kind of talk through it again. All right, so if the market rate is different from the stated rate, the bonds will sell at some price, all right, so some price other than the face value, okay, of the bonds. All right, so discount and premium. A discount is just when the bonds sell for less. Premium is when the bonds sell for more than face value. All right, so what determines that? All right, well, it depends on the rates, and we'll talk about that in a second. All right, but what this does, this allows the buyer, the person, our investor, to earn the market rate, even though the interest is being paid at the stated rate. Okay, so we'll talk about how that works in just a second. All right, now real quick, market rate, effective yield, effective rate, market yield, those all mean the same thing. They're the market rate. All right, so there's an inverse relation between the market rate and the price of a bond. All right, so if the market rate is greater than the stated rate, we are going to have a discount. And if the market rate is less, we'll have a premium. Right? So discounts and premiums are determined by comparing the market rate to the stated rate. All right, so the market rate, if you look at this example down here that we're about to do, we have 8% and 10%, all right? So we have 8% as the stated and 10% as the market. All right, so if you think about it, what's going on, if you had, let's say, so in this chapter, we're the people issuing the bonds, so we are paying 8%. If investors can go somewhere else and get 10%, why would they ever buy a bond from us? Okay, because we're only paying them 8%. All right, so to get people to buy that, we have to sell it at a discount. Okay, and then that in turns allows the buyer to earn the market rate. So what's going to happen is let's say, well, I'll point that out when we do these, when we put some numbers to it at the end. But if you think about it, if we're selling it at a discount and then we're paying back the face value at the end, that difference that we're paying helps equate the stated rate to the market rate. All right. So let's walk through an example here and determine the issue price. All right. So remember, the issue price is the present value of the expected future cash flows, which is the principal to be collected at maturity. So principal or face value, total face value, whatever you want to call it, and semi-annual interest payments in this problem. All right. So let's look what we've got here. We got 10-year, 8% bonds of $100,000 to be sold on January 1st. Interest paid semi-annually. The market rate is 10%. All right. So as I was saying up here, whenever I get a problem like this, I'm going to calculate the interest payment first, because that's when I use the stated rate. So remember, interest is principal times rate times time. Now these are semi-annually, so 6/12 or 1/2 or whatever you call it. 100,000 times 8 would be the annual interest, so I want half of that to give me the semi-annual interest. All right. So this works out to be 4,000 every 6 months. Okay. So that's so now I know my two cash flows. Remember, we are saying we have to do the present value of the expected future cash flows. So I need to determine those cash flows. All right. So here's my face value. And now I've got my interest right here. So those are my two cash flows. All right. So if you're doing, I'll show you how to do it on the calculator first. All right. So if you have a financial calculator, I think I've got like a Texas Instruments. I think it's like a BA2 plus. The 2 is Roman numerals. I've used it for years. And they're not real expensive and they're super easy to use. All right. So if I'm going to calculate the present value of my future cash flows, if you look on your calculator, you're going to have your present value keys. You're going to have an FV for future value. That's not face value. Of course, it means the same face value as the future value. All right. You're going to have a key for payment. All right. That represents the annuity, or in this case, the interest payment. So annuity is just a series of payments. So in these problems, the interest is the series of payments that are going to be made every 6 months. Okay. You're going to have a key that should just be an I for the rate, and you should have a key that's going to be N for the number of periods. All right. And then what we're going to do is hit the compute button and then present value, and it's going to kick out our answer. All right. So the future value is the amount. So think about it. This is us. So think in terms, we are the ones issuing the bonds. So at the end of 10 years, the future, we are going to pay back 100,000. Now, look, I put that as a negative. I always, when I'm doing my present value calculations, put it in as it relates to me, as it is a cash flow to me. I'm going to be paying back this 100,000 in the future, 10 years from now. Therefore, it's a negative cash flow. The payment, I'm going to be paying the payment every 6 months. So that's a negative as well. All right, the interest rate. Now, remember, now we're dealing with the market rate. The market rate is 10%. But look, this is dealing with the market rate per 6-month period. So I'm going to put 5 here. All right, don't put 0.05 as a percent, because when you hit 5 and then the I key, it knows it's an interest rate. And then N represents number of periods, not number of years. All right, it's 10 years, but there's 26-month periods. So make sure you're clear on how I got that 5 and 10. Okay, we're looking at per 6-month period here. All right, so if you run that through, your calculator should kick out 87,538. Okay, this is extremely quick to do on your calculator. You wouldn't have to write any of this out. You would punch it in and you'd have your answer. Now look, if you're using the present value tables, that is fine, okay? But realize this is going to be the present value of a dollar table, and this will be the present value of an ordinary annuity table. So on each of those tables, you're going to have to go to the intersection of 5 and 20 for the rate of 5 and the number of periods of 20, and take that factor and then multiply the present value of a dollar factor times the 100,000, the present value of an ordinary annuity times the 4,000, and then add those two together, and it will kick out 87,538. However, you can imagine the amount of time. There's a lot bigger margin for error when you're trying to deal with all that in one problem. Okay, so this problem was asking us to determine the issue price. So this right here is the issue price. And now notice we set it up here at the top that the market rate is greater than the stated rate. Therefore, we should have a discount, and we definitely have a discount here. So I'll just put DSCT because it's less than face value. So that's what we were expecting, and that's what we got. All right, so I'm going to draw a line from here down to here. All right, so think about in this problem. Read this. Let's read this again. This allows the buyer to earn the market rate. I mean, they're going to earn 10%, even though we're only paying them 8%. So think about it. We are paying them, this is $4,000 every 6 months. Okay, that's 8%. All right, or 4% per every 6 months. All right, now think about it. They are going to buy it. This is the issue price. That means that's what they're going to pay. They're going to pay $87,538 for the bonds. We're going to pay them 8% interest over the life of the bonds every 6 months. So, like I said, 4% every 6 months. But then at the end of the life of the bonds, we're going to pay them back the whole 100,000. Okay, so we're paying them 8% on interest, but then we're paying them this extra. So if you think about the 100,000 less the 87,538 is what is that? 12,462. All right, so this extra 12,462, this is the discount amount. But notice this is what they are, this is the sales price. And then this is the future value. So they're going to pay us 87,538 and get back 100,000. So this extra 12,462 on top of the 4,000 interest every 6 months mathematically makes it to where they're earning 10%. So the whole point of this is it's equating the stated rate. The bond, it's putting it on the market, with the discount or the premium, making it to where the investor will earn the market rate. Now, if it would have been a premium, it will get some number over 100,000. We'll see that in a minute. So I took a little bit extra time walking through this because you've got to be able to calculate the issue price. If you are using your calculator, real important, make sure you understand the difference between an ordinary annuity and annuity due. There's plenty of YouTube videos on how to set your calculators to that. If you have it set as an annuity due, you'll get the wrong answer. So make sure you're clear about that. You can talk to your classmates or your teacher probably about that. And if you're using the tables, make sure you're really clear on which table is which, how to use them, how to pull the factor, multiply it through, and then add together. It's more work, takes longer on the test, but you'll get the same answer nonetheless. All right. So I hope you enjoyed this. Make sure you share this. Come back and look at it if you're having trouble getting the issue price set up on a bond. And hopefully you are subscribing to the channel because there's going to be a lot more coming over the coming weeks. All right. Hope you're enjoying it. Make sure you tune in next time. Thanks.